Okay, so we can find out here. So what will be the radar range? That range of the radar is nothing but what we can define in terms of what will be the phase difference there. So we can write here what will be the phase difference. Okay, del phi. So in that case, the del phi we already say that it is nothing but what, a twice pi f0 and t is equal to 4 pi f0 r phi. Okay, that's about your del phi. Now this way we can find out the what will be the range of the radar. So this one is nothing but what, a measurement of a, what we can say that, a range of a radar. But earlier we say that when we are supposed to be transmitting the pulses, okay, in that case this one is about a pulse 1, this one is about a pulse 2. So we are supposed to receive the pulse that will be before the transmitting of the a second pulse. Okay, in between this particular duration we are supposed to receive the pulse. Okay, this is about a duration. So now in that particular time, so we are supposed to receive the a pulse here. Now what happened? Okay, we are expecting that in this particular time we are supposed to receive the a pulse here. So in that case, what happened now? Now, if we are receiving the pulse within this short duration, okay, after sending the pulse, immediately we are receiving the echo signal. Okay, immediately we are that immediately when we are receiving any signal, that is nothing but a that what we can say that it is nothing but a clutter. Okay, this one is nothing but a clutter. Okay, because this one is not any target or object, that is that echo signal received by some particular other object nearby to the device, okay, or there is any natural component, okay, in the environment, and that will reflect that particular transmitting signal. That's why we are getting a clutter. But we should have to receive the signal from this to this range. Okay, so we are expecting the signal is to be received in this particular region. So now how much is the time? Okay, that is about a time. Yes, generally we supposed to consider. So that is to be obtained. Okay, so our aim is about, if we have, instead of a pulse, we supposed to say that we have a sinusoidal signal. Okay, we have a sinusoidal signal. So now in that case, for a sinusoidal signal, so what supposed to be received from the target or object? Okay, so that is nothing but what, instead of saying that echo signal to be that is to be useful for the range, so we supposed to use that, okay, echo signal, their phase difference, and we can supposed to use what will be the reference signal we are transmitting, and that will be used to measure the range of the radar. Then what will be the unambiguous range? What will be the ambiguous? Okay, so if we supposed to consider that these two pulses, we say that these are nothing but the pulses we supposed to be transmitting. We're transmitting the pulse, this one is about the second pulse, then we're supposed to say that third pulse, like that. So we're supposed to receive the signal before sending the pulse, two pulse, okay, or we supposed to get the whatever the echo signal after sending the second pulse, but before receiving the second pulse. Okay, so that is nothing but we can say that that will be the maximum range. Okay, that is about a ambiguous range. Okay. But within this particular period of a time, whatever we are getting, that is nothing but an ambiguous one. And after sending the pulse to Okay, so we are supposed to getting the signal, we are and through that we are measuring the range. That is nothing but the unambiguous range. So that in that particular case, for a CW radar, so what will be the unambiguous range? Because we are sending the sinusoidal signal. So what will be the value of a phase difference that will provide you the range is to be ambiguous or a unambiguous? So then there are the two lines we have. If supposed to be your phase difference, then it will be of a twice pi there. Then what happened? Then that range will be what? The unambiguous. Okay, that is unambiguous. Okay. Now if that range, the difference is less than the twice pi, okay, that difference phase is less than the twice. So then what we are getting, that value is will be a ambiguous. Okay, so now in that case, we supposed to find out what will be the change in the phase between the two particular signals. And based on that particular phase, we are saying that that range of the radar will be ambiguous and range of the radar is a unambiguous one. Now that ambiguity is depending upon that what will be the phase difference between the transmitted signal and the echo signal. Now suppose we consider that whatever the signal we transmitting, or we can say that a transmitted signal has a two continuous sine wave form, and that transmitted signal has a two continuous sine wave form, and they have the frequencies supposed to be f1 and a f2. Okay, now that is about the frequency f1 and a f2. Now in this particular case, for this frequency of f1 and f2, so what will be the transmitting signal now? So we can say that your transmitting signal, okay, so I supposed to consider that the signal A, okay, it is to be transmitted. That is about what we can say that a difference sin pi f1 t, and they have the phase is about a phi 1. And then you can say that another signal sin pi twice pi f2 t, that is about a phi 2 here. Now what will be the echo signal we are getting? We say that there will be the echo signal, and that echo signal is depending upon that a frequency. Okay, if because the target is in motion, then for the for that particular target, what will be the echo signal we observe for these two particular signals? Condition is you are just supposed to be consider that this particular two signals they have the same amplitude. Okay, same amplitude, and then we supposed to send the signal now. Okay, for our understanding, we supposed to consider that the amplitude is supposed to be unity, and then we will see that what happened to the range of the radar. Now in that case, so we are getting a signal. These are the transmitted signal. Say here it's T now. So what will be the receiving signal we are receiving? Okay, or we can say that echo signal we are receiving because of that target is in motion. So there will be the shift in the frequency. Okay, that shift in the frequency is called as a Doppler effect. So we are getting this frequency component of one is nothing but with respect to that a Doppler shift here. So we will get the equation that will be sine of twice pi. This one is about f1 plus or minus FD1 here because of the Doppler shift here. D minus, this one is about a phase difference for this. Okay, 4 pi. We supposed to consider that a range here. Okay, because your object is about a fix now. Okay, so because we are sending the two signals, that is about twice pi, twice pi f1 r here, or you can see that r0 here plus whatever the phase. This is about your a signal 1. And then signal 2, that signal B here, we have received. That is again the same. Instead of F1, there will be F2. Okay, and Doppler shift frequency will be FD2. And here, instead of F1, there will be AF2. Phase difference phi 1, instead of that, there will be a phi 2. So we can write here sine of twice phi F2 plus or minus FD2 T minus 4 pi F2R. Okay, same range. Okay, so that's why we supposed to write that. And this FD1 and FD2, that is, we say that it is about the Doppler frequency shift. Okay, that plus or minus, whether your object is close, close to the radar or receding to the radar. Okay, so that is about, you can say that that is nearer to the radar or away from the radar. Okay, that is about your object. So that will define you, or that will say that is about a plus or minus sign. Okay, and from this we can find out what will be the change in the frequency, and through that we can find out that what will be the range of the radar. But at the receiver, if you consider that we are getting these two different components. Okay, because if we provide the signal, this is about a received signal. So at the receiver now, we are supposed to separate out the component. Okay, so because we are supposed to use a super heterodyne receiver type, in that case, F2 will discard it. So only we have this component, and only we have this component, because this one F2 and 5 or F1 and 5 will be discarded. So we will get at the receiver or at the detector. Okay, so what signal we are getting, or what value of the signal we are getting at the detector there, that because we supposed to use a super heterodyne type receiver now, so we are getting here the signal we are receiving from the detected at the, okay, at the receiver. Okay, that's about, can say that detected, because we are using a super heterodyne type receiver. Okay, in that case, A will be what, that will be nothing but what we are interested in, only the whatever the shift in the frequency. So that's why twice pi FD. Okay, we have a T here minus 4 pi. Okay, F1, that is about the part of your phase now. That we are expecting there. Then similarly, we are getting the signal that is about up. Okay, because we say that a separator, because we are supposed to use a mixer, then we are getting the Doppler frequencies. Okay, that is about a equation. So sine of, you can say that a plus or minus twice pi f dt minus 4 pi f2. Now only we have written here fd. We have not written that fd1, fd2 likewise, because we say that to generally that a Doppler frequency shift. Okay, because for the same radar, okay, or the same target or the same object, we supposed to send the signal frequency, that is f1, then there will be plus or minus f, okay, fd. We say that plus or minus f2 now. But what we can say that a target and everything is a fix now from the radar now. So in that case, that whatever the shift occur for a given particular frequency will be a same. So that's why what we can say that FD1 is equal to what? AFD2. So that's why we write instead of FD1 and FD2, we say that AFD. Okay. So this way we will get that FD. And from this, we can find out what will be the a phase difference component. Okay, this is nothing but a phase difference component. So we can write a phase difference component that is about a del phi, that is about your 4 pi f2 minus f1. Okay, the phase difference between these two particular components, f2 minus f1, we can say that a r0 here divided by whatever the velocity in a free space. So directly we can say that this difference in the frequency, okay, that is a f2 minus f1. Okay, this one is nothing but what? A difference in the frequency with related to the, what we can say that a Doppler frequency earlier we said. So that's why what we can say here f2 minus f1 is nothing but the difference of the or deviation in the two frequency signal. And then that will provide you, so what will be the, okay, this deviation will provide you what will be the value of a phase difference between these two components. And this will gives us directly what is the range of the radar. So R, or we can see that R0, that is about the range of the radar, that is del phi by 4 pi del f. Del f is nothing but the difference in the a frequency component, that is about it. What will be the change in difference in the frequency component? Okay, so because what we can say that del f is nothing but what? F2 minus f1. What we can say that f2 is equal to nothing but what? f1 plus del f. Okay, so this way. So that's about the difference component. So from this we can find out if there will be the range. This one is about the range measurement here. If the frequency difference and what we can say that a phase difference, so that will provide you the what will be the ambiguity in the range there. And again this will provide you what will be the error for the measurement of the signal there. So then what will be the exactly that ambiguous range? Okay, or we can say that ambiguity, range ambiguity. Okay, so generally we supposed to say that there is the ambiguity in the value, or what will be the unambiguous. Unambiguous, generally we can say that ambiguity occur if the signal, we can say that received after second pulse, then what will be the unambiguous value? Okay, so in that case, because of a two signals we supposed to be considered, and that two signals have the deviation in the frequency and deviation in the phase. So in that case, there will be the change in the phase. We say earlier that will be of a twice pi, and that will provide you the ambiguity in the range measurement. But now, so del phi, we supposed to be consider that it is not greater than the twice pi, then we will get that unambiguous value of a range. Okay, so in that case, if we provide the ambiguous range, generally we say that it is about it with respect to that maximum is about a twice pi now. Suppose I consider that is about maximum limit. Okay, so in that case, limit for that maximum of a twice pi is twice pi and 4 pi. Okay, so it will be cancelled here. So we are getting only what? the factor is about a 2 and this is about a delta. That is about the limit. So this way we can say that the value of the maximum unambiguous range that will be defined for this multiple frequency CW radar. And then in that particular case, so if we supposed to find out what will be the error in that particular range measurement, that errors are defined, or we can write the equations of the error for this range measurement. Okay, so that is about a RMS range error here. So that is defined C by 4 pi del F here. Okay, and then this is about what will be the energy we supposed to be transmitted with respect to the a noise. Okay, because this one is about a modified equation. Okay, this one is about a modified equation we supposed to use for the measurement of the range. Now this one is nothing but what? A error. Okay, this one is nothing but what we can say that the error for the measurement of the this. This is about your energy of the received signal. This one is about a noise that is at the receiver there. Okay, so that's why what we are getting, and this one is about your full spectrum for the given particular range measurement. So that's all about what we can say that a multiple frequency measurement here, and we know that ECW radar as well as the FMCW radar that we have seen, that will be useful for the measurement of a range as well as the measurement of the velocity. And we have seen that one of the application of the FM radar, FMCW radar, that can be used as the altimeter that is useful for the measurement of the height. With this, we stop here. So thank you all.